Let's talk about sources of light. These are things that give off or create their own light. The light from them is going directly into our eyeball. There's no bouncing around in between. This is a yellow ball that's really fun. Right now we can see this ball because it has some light from the room bouncing off of it, or it has my flashlight bouncing off of it, or reflecting off of it. But if I turn it on, now this ball is its own source of light. Now it is creating light, so it becomes a source of light. So if it's off, it's not a source of light. Not creating light, not giving off light. I can only see it because light is reflecting off of it. But if I turn it on, now I can see it because it is a source of light. It is creating light that's going directly into my eyeball. There's no bouncing around. It's just coming right to me. Okay? So, source of light, not a source of light. Now, in order for us to see any of these sources of light, the light has to travel from the source to our eye. When it travels in that straight line from the source to our eye, we call that a ray. Maybe you've heard someone talking about a ray of sunshine. Rays are what we call light that travels in a straight line from the source to our eye. A ray of light hits other things before it hits my eyes. Those things can have very different behaviors. And what we can call those is the three main ways that light will interact or behave with different things. So first we have things that are opaque. This one's very easy. It's kind of a weird looking word, but opaque just means no light's going to pass through it. So if I have a light shining in my face, oh that's bright, and I put something that's opaque, like this piece of cardboard, in front of the light, it's gonna totally block that light. You guys cannot see any light coming through this piece of cardboard. So this piece of cardboard we would call opaque. Opaque, that's a Q. And that is not gonna let any light in. None of the light will be able to pass through this piece of cardboard. Next up, we have things that are translucent. Translucent things will let some of the light through. So if something is translucent, think of it as blocking a lot of the light but still letting some through. So once again, why do I keep doing that? I have my flashlight, now I'm gonna put a piece of paper in front of it. Okay? Now, it made the light a lot dimmer. It blocked a lot of the light, but it did not block all of the light. As you can see on my piece of paper, you can still see some of the light coming through. That means that this piece of paper is translucent. Translucent means some of the light can get through. A transparent thing will let through almost all of the light. Will go through something that's transparent. So something that's transparent might be the piece of glass that's in the front of my flashlight here. It could also be the glass in my safety goggles. These won't protect me from the sunlight, but they do let me see everything around me without darkening it, and they're not gonna let through solid things, but all the light in the room can still come into these glasses. That's because these lenses are transparent. They let all the light through. At reflections. Here I have the camera set up on my bird bath. As you can see, the water is pretty still, but if the water starts to move at all, here I'm going to shake it, then that reflection will start to get really wonky and won't look right anymore. But then once the water starts to still again and the surface becomes smooth, the reflection becomes much clearer. However, if the surface of the water becomes rough, that reflection is not as clear anymore. So this is the difference between a smooth surface and a rough surface and how it can create a reflection. See that very clear reflection happening when the laser hits the mirror. And if I change the angle, if I go up higher, then it'll bounce back up higher. This is just like a ball, remember? If I bounce the ball at an angle away, then it'll move away. If I bring it straight up, then it'll come straight up. So this is a very clear example of how that reflection works, how the light will move in a straight line until it bounces off of something to change direction. If I shine the laser on the aluminum foil, you can see that there isn't a clear bouncing off. It kind of the light that's reflecting off of it keeps changing direction as I move the laser. This is because it's not a smooth surface, so we're seeing that reflection go all over the place. Now, when we say refracted light, we can easily just think of bending light. Actually, the light is bending as it passes through things. When we can see the bending of that light, so here's my laser shooting out, and I'm going to send it into the glass ball, and you can see it's going in one end and out the other. Now I want you to watch very carefully and raise your hand when you see the light start to bend. Here we go. When is the light going to bend? So right at the edge of the ball, just as it's about to leave, we see the light from the laser starting to bend. And as you know, light will always travel in a straight line unless something is there for it to bounce off of or for it to pass through and then bend. So as you can see, I'm getting some refraction as the laser is bending through this glass ball. But look at the angle that I'm holding my laser at. Does it look like the angle is correct as it goes into the water? Watch it when I dip the laser into the water. Notice how the angle changes from in the water to out of the water. This is that bending of the light that we see in refraction. So what's happening here is it's much more difficult for the light to travel through the water because it's so much thicker. It slows down. So that's why the angle changes, because it's got to travel slower. But when I put the whole laser in, now the whole thing is traveling that slowly, so it looks like a straight line. Absorbed light. Absorb means to take in and hold something, the way a sponge will absorb water. Well, light can be absorbed too. If something is green like a leaf, it's absorbing or taking in and holding all the colors except for green, which will be bouncing off of that green color, like a leaf. So this is also why white colors appear white, because they are equally reflecting all of the colors of the rainbow, so it stays looking white. And this is also why black colors appear black to us without any color, because something that is black will absorb and hold all of the colors. There won't be any colors that bounce off of something that is black, so it looks like the absence or all the colors are missing, which is what black looks like to us. Let's have a look at how our experiment went. I have the ice that was on the white paper right here, and the ice that was on the black paper. Let's take a closer look at which one is larger. As you can see, the ice that was on the white paper is clearly much larger than the ice that was on the black paper. Now, who can explain why the ice that was on the white paper is not as melted as the ice that was on the black paper? Remember, darker colors will absorb more light than lighter colors. This will make them start to turn that light energy into heat energy, which will warm them up. So dark colors will get hotter than light colors.